Okay, so this time we're going to find the derivative of y with respect to x of this equation that says y is equal to the sine of xy. Alright, so if I took the derivative of this, the derivative of y with respect to x would just be 1, and dy dx, since we took the derivative of y with respect to x. And then in this one, we gonna need to be careful to do the chain rule here, because we're taking the derivative of, we've got some stuff inside that does not have a derivative of 1. So the derivative of sine of something would be the cosine of that something, and then we need to multiply by the derivative of the stuff inside. Okay. Well, even though there's only two things inside, taking the derivative of this is going to be the product rule, because it's this times this. So if I take the derivative of the first term, that would be 1, times it by the second thing. Sorry, not really a term, but derivative of the first part was 1 times the second part unchanged. And that was the derivative of x with respect to x, so I don't need a dy dx here. Plus, now I'm going to take the derivative of this, which would be 1, but now I'm taking the derivative of y with respect to x, so I'm going to need my dy dx here, or my y prime if you'd rather, same thing, times the first term. And since these are 1s, we don't really need them. Okay, so it helps that I have this in a little different color here to help you see this, but this is really, so I took the derivative of this, which was this, times the derivative of the inside part, but I need to make sure that it's times all of this. It's not really just times the y and then all of a sudden plus x y prime. Okay, well I guess if I'm writing y prime over here, I should be consistent, and you can pick your own preference if you want to. But now, so we've got the calculus done. Now I'm trying to solve for y prime. This one's a little bit harder than the last couple questions. The algebra will be a little bit harder because we've got a y prime here and a y prime here. So in the end, I need to do whatever it takes there to solve that for y prime. Alright, so I would suggest to you, go ahead and distribute this so that this y prime is not caged up in these parentheses. So that would be a cosine of xy times y plus an xy prime cosine of xy. And now we want to isolate our variables. So in other words, anything with y prime on it, we need to either get it to the left side or the right side. So if I subtract all of this from the right side and subtract the same thing from the left side, I will have achieved that. I now have all my y prime stuff. All my y prime stuff, at least it's all on one side now. Okay, so then an algebra trick that we need here is I've got some y primes and I've got some y primes, but I can't really, like, 1 and x cosine of xy's are not like terms, so I can't just like force them together, or I can't force them in the same way that constants do. Like if this was 5y prime minus 3y prime, obviously I know that's 2y prime. That's easy to combine those together. So instead you might think of this as like a GCF. Both of these have a y prime, so it could be factored out. And that works out great for us because now I've got what I'm trying to solve for times a bunch of stuff. So let's divide it away from the left side and keep it balanced by dividing it away from the right side. And so it's kind of messy here, but all of this should be our answer. All of that is the derivative of y with respect to x.